Welcome back, folks. Doing more nodal analysis using the shortcut method or nodal by inspection. We're going to look at our next op-amp problem that we've looked at in the past. I took the liberty. I set up the matrix before so you don't have to hand. Oh, wow, look where that line is drawn. That's like perfect. It's like I can reach into the matrix and... Cool. That's what passes as fun for me these days. Forgive me. Okay, so we've got to look for our unknowns. Okay, so we have our unknown node voltages A, B, and C. All right, we can label those like that, and then we have to make our plan like we've done in the past. So I'm going to write I see a voltage supply, so I'm going to write a KVL for node A. I see an op-amp, so I'm going to write a KVL for the op-amp. And then I have to avoid this one, and I have to avoid this one. So that leaves me with B again. So I'm going to write a KCL for B. Okay, so I have my plan. Let's go do it. VA is connected to the positive side of the 10 volt. Ground is the negative side, so everything else is 0. All right, right-hand side is 10. That one's done. VA is the positive side of the op-amp, so it's going to be 1. VB is the negative side, so I can say -1. And then everything else is 0. And since it's an op-amp one, it's 0 on the right-hand side. Okay, 2/3 of the way there, really quick. We're still under 2 minutes. Ready? Go. We got to write the KCL. What is attached to B that is also attached to A? Nothing. What is attached to B? And that's the one we're writing the equation for, so it's going to be 1/4 plus 1/12. Okay. And then what's attached to B that's also attached to C? The 12 ohm fits that bill, and since it's attached to something else, it's negative. There are no current supplies connected there, so it's equal to 0. Okay, calculator time. 3 by 3, 1 0 0 10, 1 -1 0 0, 0 4 inverted, 12 inverted. I'm pretty sure that's 1/3. Yes, it is. And then -12 inverted and 0. Okay, and that gives us a solution of 10 volts, 10 volts, and 40 volts right behind me. Okay. Done. What did I do? Under 3 minutes with a little bit of talking, and I had to write it out instead of just doing it right in my calculator. But there we go. I think you can start to see that with a little bit of practice, you can do these quickly. Let's check ourselves. You'd have to use these before we check ourselves. We'd have to use these to then go find I out, right? But once you know the mesh currents, well, this is true, but once you know the nodal voltages, how about that? You can go find whatever value you need to from previous video. Okay, and let me go grab that for you. Where'd it go? All right, found it. And there it is, and you can tell it's from the previous video because it was kind of overcrowded there and I couldn't get the other stuff away. But it looks like we got the same solution, and if we pick apart the matrix, we can see that we have an equivalent system. Almost identical, except for the signs on this last one. Okay, pretty good. 2 more of these just to practice, so that we have plenty of practice, plenty of examples for you to look for when you're trying to do this yourselves. Okay, stay tuned, and good luck.